revise the previous class. And in this question, you just ignore this part. What do you understand by isoelectronic species? No. What has happened? Moving on. Okay, if you guys can hear me, I have to restart my computer. Okay, so I will join in a while. No, this is what happened. Okay, I will join in a while. Okay, guys. I will share the screen. Okay, just a second. By the way, Devangi, what happened? What did you guys hear? Like, were you able to hear anything? Because my system got stuck. Yes.
So we have to solve the questions now.
You have to write the question. Okay. Yeah. No, I'm saying that. Did you guys hear anything, or did I just go off? Not me, but the computer. Sorry.
Sir, I heard.
Okay, you all had. Okay, fine. So I think everything was working except the screen. You guys have to send the answer on WhatsApp, okay? Okay. कीजिए. It's 4 questions. It will take a bit of time.
Hey, did you receive mine?
Yes, Fatima, I received yours. Okay, so let me see. First one, yes, correct. Look for the D1. Can you try the D1 once more? Rethink now. Okay, fine. Sorry, my bad. Sorry. Your answer is correct. And then we have, yeah, okay, fine, correct. Second, which of the following pairs, which species has largest size? Oh. Second one, can you please rethink which one has larger size, no? Fatima, can you try once more?
Yes.
Okay, and the last one could not. Okay, fine. I'll explain the last one. Others also, please send the answers, whatever you have done till now. Devangi, I have received yours. Devangi, you had not do the first one. Second one, correct. Correct. Lithium plus or sodium plus? Yes, fine. Phosphorus, okay, fine, correct. Yes, Devangi, those answers are right. Very good. And for the third question, okay, third question I will see. Okay, third question हम यहाँ पे करेंगे तब आप देखिए. Okay. Abdullah, seeing your answer. Fahad, you have not sent me the answer. Iram, you have not sent me the answer. And Fatima, you try once again for the second question, the example 13 that is written here. Okay, fine. Yes, Abdullah, the first one, I think you are correct. Okay. Okay, okay, yeah. Those two answers are right. And for the last, this question, example 1, 2, I will solve it here. Correct. I think fifth one you're having a problem. Do you remember this, Aisha? This group, phosphorus and acetylene? Yes or no? Tell me. For phosphorus and arsenic, do you remember the group?
No.
No. That means you can't make the periodic table now. जितना भी हमने पढ़ाया उसका. Yes, Fatima. Nana Patekar. Can you complete that? Ashwarya. Aisha. Aisha, can you complete this? Nana Patekar. Who remember this? Tell me now. This group. No one remembers. Okay. Yes, Fahad, tell me. Can't hear you, Fahad. Can't hear you. I can hear someone in background, but not you. Okay, fine.
Yes, sir. Sir, it would be nitrogen, phosphorus, AS, arsenic,
Arsenic.
SB, antimony,
Yeah. Correct. And bismuth.
BI, पता नहीं क्या.
Yeah. Bismuth. Okay. So, Nana Patekar, Ashwarya, sab bimar. Aisha, you don't remember this now? See, first of all, what we have to do here, we will identify the block. So this is P block, and it is having 3 valence electron. That means it is going to be in 13th group. Here also it is P block because the last electron is going on the P subshell. So here it is P, and it is going to be having 10 plus 3, 13th group. This is having 3 plus 2, and this is also in P block. That is why this will be in 15th group. This is having 5 plus 2, that means 7 electrons in the, and it is also in the P block. So if it is in the P block, then the valence electron plus 10, that is equal to 17. And this is in the S block, and hence it is going to have the group number 2, because in S block, the group number, it is equal to the number of electrons in the valence shell. Now, here we can say that A and B, they both lie on the same group. In each of the following pairs, which species has a larger size, Br or Br negative? So obviously, Fatima, you did this one wrong. Fatima, what is the order?
Yes, sir.
You got it?
No.
No, you did not get it. Okay, tell me. What is the order for cation, anion, and neutral? Cation, anion, and neutral. Which has the largest size?
Sir, cation.
No, you have not revised. Please look at your notes and tell me.
Sir, it's cation, neutral, and then anion.
Did you not write this?
Sir, I
Fatima?
just told them.
You just told me. Okay, fine. So anion will be the largest, right? Yes or no?
Yes, sir.
So in Br and Br negative, what will be larger, Br or Br negative?
We are negative.
Br negative. O2 negative or F negative, which will be larger?
O2 negative.
O2 negative, because they are in the same. See, you have to see the period also, because they are in the same period. Then only you have to see the. Because if the period will change, the shell number will change, and then you have to talk in the terms of shell number. But right now you are having this in the same period. That is why it is going to be O2 negative. Now then we have K and K plus. So obviously K is neutral, so it will be having larger size. Lithium positive and sodium positive. Now you can see now there is a change in the shell number. So which is larger, lithium or sodium?
Lithium.
Lithium नहीं है, sodium. Linak rub kasfar. Linak rub kasfar. So sodium is going to come after lithium, and that is why it is going to have a larger shell. Now then we have phosphorus and then arsenic. So that is Nana, Patekar, Ashwarya, Sub, Bimar. And this is going to be having AS. And then we have Na plus or Mg2 positive. Then obviously here we have both of these, Na plus and Mg2 positive. They are in the same period. Now you have to look at the charge, which is having lesser charge. Na positive is having lesser charge, so that is why it will be Na positive. Now let's look at this one. Arrange the following ions in the order of increasing size. Now we have beryllium, chlorine, sulfur, sodium, magnesium, and bromine. So is everything in the same group? Yes or no? Please tell me. Is everything in the same group?
Yes.
Yes. They're in the same group.
No. After like, they are all in the like the configuration would be in the noble gas group.
No. Their configuration is going to be noble gas. That's not. We are not worrying about that. Are they in the same group? Tell me, beryllium is in which group?
No.
Beryllium is in. Sorry, not group. Which period is it in? Beryllium.
Second.
Second period, right? And chlorine. Fluorine and then chlorine. So it is going to be third period. Sulfur 2 negative. Sulfur is in which period? Tell
Third.
me. Third only, right? Sodium. Sodium, third, right? Yes or no? See, above this we have hydrogen, helium, hydrogen, lithium, and then sodium.
Yes, third.
And then we have Mg2 plus, it is also in the third. And then we have Br negatives. Br negative is in fourth period after chlorine. So tell me which one of them is going to have the largest shell? Which is going to have the largest shell here?
Bromine.
Bromine is going to have the largest shell because in the fourth period, that means it has fourth shell, right? This has third shell at max. So Br negative is going to be the largest, followed by. Now, when I look here, I have many third shell. So if I have many third shell, in this case, what is going to happen? The one with the highest charge, highest negative charge, that means S2 negative. After that, we'll have chlorine negative. After that, we'll have sodium positive, which is having the least positive charge. Then we will have Mg2 positive. And then will come the Be2 plus, which is in the second period. Please write this down. Also, you can see what they're asking, give a formula of a species that will be isoelectronic with the following atoms or ions. So fluorine negative you can write, or you can also write oxygen 2 negative.
Sir, can you write it from the other way?
Sorry?
Sir, can you write it from the other way?
Can you write it other way?
Positive.
I mean, you can write it, but it will be like this then.
So like nothing.
The arrow will change now, Fatima.
Sir, so is it stronger or not?
I can't understand. Can you please say it properly? Your voice is very.
Sir, is it wrong or right? Is it also
Which
like
one?
That way. The second one.
Wait a second.
Sir, the arrow in the other side.
That will be wrong now. You're saying you have put the arrows like this. Huh?
Yeah.
No, sorry. No, it is fine. Correct. My bad. I was writing it wrong. There is no difference between the white one and the blue one, no? Correct?
Yeah.
There is no difference. Same thing. Okay. Will be isoelectronic. That means fluorine negative will have same number of electron as O2 negative. And you can also rather, if you just not want to complicate things, then you can write C. F negative is having the same number of electrons as of neon. That means 10 electrons, right? So you can write here. F negative, I will write two examples. You can write for F negative. It has the same number of electron as O2 negative or N3 negative or neon, as simple as that. Second, you have argon. So argon has how many electrons? It has 18 electrons. Now before argon, we have chlorine. So it will be chlorine negative will have same number of electrons, or you can also write S2 negative. And then we have Mg2 positive. So Mg2 positive will have only 10 electrons. So this will be isoelectronic to F negative. Okay, F negative also has the same number of electrons, or you can also write neon. Then we have rubidium positive. So rubidium is in the which period? Tell me. Rubidium will be in which period? 5th period, yes or no? Lena corrupt cusper. 1, 2, 3, 4, 5. 5th period, and the 4th number is krypton. So this will be isoelectronic to krypton. Okay, so NCERT expects that you know at least the S block and the P block and the first 3 transition series. Write this down, everyone.
So can you check my answers once?
सब तो बता दिया हमने, कौन सा नहीं बताया बताइए? आपका 4th वाला?
सारे मतलब मेरे आंसर को चेक कर लीजिएगा और सही है।
अच्छा, आपके आंसर चेक कर लें हम। क्वेश्चन नंबर 3 में आपने सोडियम छोड़ दिया है,
ये से वो भूल गया।
है ना? फिर Br negative, O2 negative, K, I think that one is fine, no? K, and then you have sodium. K के बाद sodium positive होगा, हमने यहाँ पे गलत लिखा है. And then you have arsenic and sodium positive, ठीक. Okay, आपका 6th वाले में sodium positive छुटा हुआ है बस, है ना? Nothing else. Neon, and then you're writing argon का chlorine negative. हाँ ठीक है, सही है. And then you're writing for Mg2+, it is like neon. Yes, correct. Krypton also, yeah, correct. Those are fine.
Okay.
Okay. Please write, all of you who have not written. Give you 1-2 minutes,
So-
and then we'll start to discuss. Yeah, tell me. Yes, Kiran.
So could you explain? Yeah. So could you explain isoelectronic species?
Isoelectronic species. Do you remember the formula? Do you have you written the formula? Sorry, have you written the definition
So-
in the?
No. So I was not present in class.
So
So
आपने
I've
रिकॉर्ड
not
नहीं
written
किया.
it. No.
Okay, fine. Are you well?
Yeah.
Okay. So isoelectronic species. Iso means same. Electronic means same electrons. So they will have same number of electrons. When 2 species, they have same number of electrons. So if you look at F negative, then F negative has 1 more electron than the fluorine. So fluorine has, simple fluorine has 9. That is why F negative will have how many electrons? Tell me. Iram?
10.
10 electrons. Right, will have 10 electrons. Similarly, if you have, let us say, sodium positive. What is the atomic number for sodium neutral?
11.
11, right? Yeah. So sodium positive will have how many electrons?
10.
Yeah. Understood? So you can see fluorine
Yes.
negative and sodium positive, both of these are isoelectron. Correct? Okay. But please watch the lecture, huh? If you're absent, then you have to watch the lecture. Don't skip them. Okay, fine. So last class, what did we do? So in the last class, we were talking about ionization enthalpy, and I think, right? Okay, so most loosely upon. Correct. Next. Successive ionization enthalpy. It's a small topic here. Successive ionization enthalpy. Okay. In successive ionization enthalpy, for example, we have this iron atom, right? So iron, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Atomic number is 26. Now, when I'm going to remove the first electron, from Fe, I will get Fe positive, and one electron will be removed from Fe. Now, in this case, Fe positive is going to have an electronic configuration of, I can write this part as argon, yes or no, tell me? 18 electrons now. I can write this as argon. Now, this 4s2 will, there will be an electron which will be removed from 4s2 because it is the outermost electron. Fourth shell is the outermost shell, and we are going to remove the electron from the outermost shell. So we will have an electronic configuration of 4s1 and 3d6 like this. Now we can remove another electron from Fe positive. If I will remove another electron from Fe positive, what will we get? Tell me. Fe, what will be the charge? If I remove one more electron from Fe?
Fe2.
Yeah, very good. Fe2 positive. And this will also give me one electron. Now this is going to have, now Fe2 positive will have electronic configuration of argon. 4s will now be 0 because the outermost electron is 4s. That will be 0 and we'll just have 3d6. Now you can have Fe2 positive and you can remove one more electron and I will get Fe3 positive plus one electron. Now in this case, when we have Fe3 positive, the electronic configuration is going to be argon. You don't need to write 0, but I'm just showing 4s0 and there will be 3d5 because now the outermost electron is in the third shell, that is in the 3d6 subshell. Now this is known as the first ionization enthalpy. We write it IE1. We write this as IE2 and we write this as IE3. Now, as we are moving, as the ionization enthalpy, we are going to successive ionization enthalpy. We can see that here I am removing, in the first case, I'm removing an electron from a neutral species. In the second case, I'm removing an electron from a charge that is also positively charged. And here I'm removing an electron from two positive charge. Now, can you guys tell me which will be the toughest? Which will be toughest, i.e. 1, 2, or 3? If I want to remove a negatively charged electron, please remember negatively charged electron, will it be difficult in the neutral case or in the positively charged case? Where will it be difficult to remove the electron? Aisha, tell me, what do you think?
Positively charged.
Devangi, what do you think? Okay, Aisha. Devangi, what do you think? Where it will be difficult to remove the electron from neutral or positively charged? Say. Yes, Devangi.
Sir, I think neutral.
It will be difficult. Okay. Iram, what do you think? Where will it be difficult to remove the electron from positively charged or neutral atom? Iram, tell me.
So I don't know.
Okay, fine. And what about you, Fahad?
Positive.
Okay. Fatima, what do you think?
Positive.
Okay. Muhammad Abdullah, what do you think? Muhammad Abdullah, can you please turn your mic on? Yes, Muhammad Abdullah. Yes or no, or you don't know? Can't say. Okay, fine. I think Abdullah is not here. Okay.
Sir, I think third case.
Third case. Okay. So see, Muhammad Abdullah, you have to turn your mic on. Okay. These things I cannot always look at the chat now. And also I need answers quickly. Otherwise, I will be just waiting for answers. Okay. Iram, you think in this way. All of you think in this way. What is the charge of electron, Iram? Electron's charges, positive or negative, Aram?
Negative.
Negative. So if we have a charged, positively charged species, then what it will do, it will attract the electron more efficiently, yes or no, than the neutral atom.
Yes.
So if I will have a positive charge, then in that case, removing the electron will be difficult, right? Because positive charge is attracting the electron, correct?
Yeah.
That is why it will be difficult to remove the electron. If it is difficult to remove the electron, then I will be requiring a larger amount of energy in the positively charged case. So this order will be ionization enthalpy 3 will have the highest value, followed by ionization enthalpy 2, and followed by ionization enthalpy 1. Okay, as we on successive ionization enthalpy, what is happening? We are requiring more and more energy. Okay, right here. The energy required to remove subsequent electron of an atom in gaseous state is called successive ionization enthalpy. Right remarks? Ionization enthalpy are always positive. Smaller the value of ionization enthalpy, easier it is to remove electron from that atom. Right, the last point. Metallic character increases with decrease in ionization enthalpy. Then everyone is going to be seeing me. All of you wrote this question now? Okay. Right, next. Factors affecting ionization enthalpy. Okay. Number 1. Size of atom. Okay. Tell me, guys, what is going to happen if I have a larger size? If the electron is away from the if it is away from the nucleus, then will it be easier to remove electron or difficult to remove electron? Tell me. If I have an electron close to the nucleus and I have in the another case electron that is away from the nucleus. Which will be easier, A or B? B will be easier, right?
B.
That means we are going to require less energy, in the B case. So you'll write. Guys, please answer this, okay? When I ask questions, I don't hear Aisha and Iram answering. Aisha, Iram, and Fahad, Abdullah, all of you guys. So please answer. At that time only I will understand whether you are understanding or not, okay? So please write ionization enthalpy decreases with increase in size of atom. Also, those who are more okay with this proportionality sign, is it is inversely proportional to the size of atom. Right, next, charge on nucleus. Rather, charge on atom. Okay, so we can say that ionization enthalpy is directly proportional to positive charge on atom. Because if we have a positive charge, that means it is already ionized. We have removed already one electron. It will be difficult to remove the another electron. Okay, so ionization enthalpy also depends on the charge on atom. If it is positively charged, that it is going to have a higher ionization enthalpy. You'll write here, third, screening effect. Screening effect of inner electrons. Now, it's very important to understand, first of all, if the screening increases, that means the inner electrons are shielding the outer electron. It is not, the inner electrons are not letting the positive charge to reach the last electron. If the screening increases, attraction will decrease. And if the attraction is decreasing, that means it will be easy to remove electron. Right? It will be easy to remove electron. And if it is easy to remove electron, then we can say that ionization enthalpy is going to decrease. Right? We will require less energy, less ionization enthalpy. And hence I can write ionization enthalpy is inversely proportional to screening. Screening effect. Yes, tell me. Yes, Iram.
So what is screening?
Okay, Iram, this is like really a request that please watch the lectures if you're absent, Hannah. Okay, but see here, देखिए, आप इसमें बताइए हमें. Look at the blue electron. In both the cases, I have two shells. Yes or no? Tell me, Iram.
Yes.
Because I have two, A and B. But what is the difference? In A, I have inner electrons, correct?
Yeah.
Yeah. But in B, we don't have any inner electron, correct? Yes.
Yes.
Okay. So what do you think? Which will be attracted by the nucleus more effectively, the A case or the B case? This blue electron will be attracted more easily in the A
B
case or the
case.
B case, right? So inner electrons, what they are doing? They are shielding the positive charge, right? Yes or no? They're not letting the positive charge to reach the electron, correct?
Yeah.
That is a screening. You understood?
Yeah.
Okay, but there is some detail again, okay? Please watch the lecture, complete the notes. Okay. Screening effect. And then we will write next, fourth point. Penetration effect. of subshell. So we know that S subshell is nearest to the nucleus. That is why if an electron is present in the S subshell, and in the same shell, I'm talking in the same shell, if it is present in the S subshell, it will be requiring more ionization enthalpy, followed by P, followed by D, and followed by F. Okay. So S will have the highest ionization enthalpy in the same period, in the same shell. If you're talking about the third shell, then in that case, 3s electron will have higher ionization enthalpy than the 3p electrons. So that is also one of the factors. Right, the fifth point. Electronic configuration. In electronic configuration, we know that half filled and fully filled configurations, half filled and fully filled configurations are more stable. Hence, it is difficult to remove. To remove electron from half filled and fully filled subshells. Done, everyone? Yes, no, please tell me.
So can you scroll up for just 2 seconds?
Yeah, sure. How much up?
Yes, that's fine.
So could you explain the last point?
Last point. Okay. Devangi, have you learned this electronic configuration half filled and fully filled? Yes or no?
No, sir.
No, not right now. Okay. So see, if you have a configuration like this, you understand this configuration? Yes or no, Devangi? No. Devangi, do you recognize
sir.
this orbital? No. Oh, that means you're not watching the lectures, right? Yes, Devangi. How many lectures have you watched? Tell me.
Sir, 2.
Sorry?
2.
Only 2? If you will not watch, then how will you understand? 2 बोल रही हैं आप, 2 में हमने नहीं पढ़ाया है सेकंड लेक्चर तक. It is there in the third lecture. If you are not going to complete Devangi, then what's the use of lectures? If you have recordings.
So can you show the first point? Okay, that's fine.
Okay. Devangi, tell me, P can hold how many electrons? P subshell. Maximum number of electron P can hold is how much? Devangi?
6.
6, very good. So if it is 6 electron, then we show the p orbitals like this. See, we have 3 p orbitals, 1 electron, 2 electron, 3 electron. If it is this configuration, if it is p3 or it is p6, 3, 4, 5, and 6, p6, then both of these configuration are more stable than, for example, if you have, let us say, p4. Okay, so here there is complete symmetry. That is why it is more stable. There is a few bit more to this, but you can understand that both P3 and P6, these are symmetrical, yes or no?
Yes, sir.
But P4 is not symmetrical. It has 2 electrons here and 2 electrons are not having any pair. So these are more stable than P4. Okay, so for a brief understanding, you can just understand this part. Okay, now you guys will write variation along the period. Those who guys now who are not revising and not like looking in the notes and coming to the lecture, it is going to be very difficult this chapter. Everything will look like a fact, but it's not a fact actually. If I will ask you guys, what do you think, what is going to be the variation along the period if I am going this way? In general, I'm asking just the trend, whether it is going to be increasing or decreasing, the ionization enthalpy. Okay, so I have, where should I start from? Say lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Tell me guys, if I'm going from lithium to fluorine or neon, then what do you guys think what is happening? And will the ionization enthalpy increase or decrease? Tell me in the chat. What do you guys think? I've shown you the factors. You can apply the factors and then answer this also. Okay, Fahad. Okay, Ram. Think about this. What is changing here? Think about that. Fatima, Devangi. Okay. Fatima, can you tell me why? Fatima, can you tell me why?
Sir, because the size is decreasing. I mean,
What is happening? What is happening? What is happening? You said it right. Sizes?
Sir, the size across the period, the size is increasing.
Size is decreasing. Okay, fine. If the size is decreasing, then the electron is nearer to the nucleus or further away from the nucleus?
Away.
Size is decreasing, so it will be away from the nucleus.
Yeah.
Again, size is decreasing or increasing? Fatima?
Increasing.
Increasing. Size is increasing. So it will be away from the nucleus or near to the nucleus? Electron will be away or it will be near?
Away.
Away, right?
Yeah.
So it will be easier to remove an electron which is away from the nucleus.
Yes.
So if it is easier to remove the electron which is away, yeah, okay, fine. Though your first thing is only wrong. Size is increasing, you're saying.
I said in the beginning, size is decreasing.
Okay, size is decreasing. If the size is decreasing, then the electron will be nearer or further away? Electron will be
near.
If it is near, then it will be difficult to remove electron or easy to
Yeah.
remove electron?
Difficult.
If it is going to be difficult, then what do you think? Ionization enthalpy will increase or decrease? Ionization will be higher for this difficult thing or lower? If it is difficult to remove electron, then we will need to put more energy or less energy?
More energy.
More energy. That means ionization enthalpy will, sorry, if I have to put
Increase.
more energy, increase, na? Okay. Fine. So this is the general trend. Very good, guys. All of you answered correctly. बहुत बहुत शुक्रिया, हमें बहुत रिलीफ मिली. I hope आप लोग को भी रिलीफ मिला होगा. Okay. So right here, in general, ionization enthalpy increases with increase in atomic number. You'll write in bracket moving left to right in a period. In a period. Next, you write it happens due to number A, increase in nuclear charge. That means lithium has less number of protons, then beryllium has higher number of protons, and boron has higher, and carbon has higher, and slowly. But you can see that the number of shell is same. So if you have more nuclear charge, then it is going to pull more easily. And also the B part, decrease in size along a period. Okay, so these are the two reasons. Okay. Now you'll write next point. There are some irregularities. The trend is fine. The trend is it is increasing. The ionization enthalpy is generally increasing with increase in the atomic number in a period. If you are going along a period, then it is going to increase. But there are some irregularities, and we will focus on them now. Irregularity in the trend. In the first irregularity, we have beryllium versus boron. Beryllium versus boron. What did we expect? Tell me, which will have higher ionization enthalpy, beryllium or boron? According to this trend, which should have higher, beryllium or boron? Ionization enthalpy is increasing. So in this trend, what is going to happen? Which will have higher ionization enthalpy, beryllium or boron? What is expected according to the trend? Tell me, guys. Aisha, which will have higher ionization enthalpy, beryllium or boron?
बोरोन
Boron should have the higher ionization enthalpy. क्यों आप लोग नहीं बोलते? इतना आप लोग से पूछना पड़ता है. Ionization enthalpy. Okay, Devangi, you can rejoin. Is my voice breaking for everyone? Is my voice breaking? No. Okay. Ionization enthalpy of boron was expected to be higher than ionization enthalpy of beryllium. But actual is, what do we have? Ionization enthalpy of boron. It is what? It is less than ionization enthalpy of beryllium. Why is that? It is because of due to more penetration power of S subshell. You see here, if I write the electronic configuration of beryllium, let us write first. Beryllium has the electronic configuration 1s2, 2s2. Boron has the electronic configuration of 1s2, 2s2, and 2p1. Okay. Now the increase in atomic number is just of 1 unit, right? You have increased the atomic number by just 1 unit. But right now, if you see there is a significant change, we have the last electron in the S subshell, which is very near to the nucleus. Now in boron, we have the electron in the p subshell, which is further away from the nucleus. Now, since s electrons are nearer, it will require higher energy. It will require higher energy. Okay, so please write. It is easier to remove electron from 2p as it is more diffused and away from nucleus. Okay, and away from nucleus. Furthermore, the 2s subshell in beryllium is completely filled and it's difficult to remove electron from Be. Then everyone is on, please tell me. Write this, then we'll write the second one. Nitrogen versus oxygen. We expect that ionization enthalpy, nitrogen should be less than ionization enthalpy of oxygen, right? But what do we see? Actual ionization enthalpy of nitrogen is rather higher than the ionization enthalpy of oxygen. The reason is half-filled and fully filled subshell. Okay, reason. Half-filled subshell of nitrogen. See here, the electronic configuration of nitrogen is 1s2, 2s2, 2p3. Oxygen is 1s2, 2s2, 2p4. Okay, so there is not a significant change in the atomic number. Only one atomic number has changed from nitrogen 7 to oxygen 8. But we have changed from half-filled, more stable configuration to partially filled, less stable configuration. That is why it is easier to remove electron from oxygen rather than nitrogen. You'll write here. Since nitrogen has half-filled 2p subshell, half-filled 2p subshell configuration, which is more stable than partially filled to P4 of oxygen. It is difficult to remove electron from nitrogen than oxygen. At last, you'll write a note. As noble gases have the most stable electronic configuration. They tended to have very high ionization enthalpy corresponding to their period.
Done, sir.
Done, everyone? Is there anyone who is still writing? No. Okay. Right, next. Variation in group. Tell me, guys, what do you think? What is going to happen? Ionization enthalpy will increase or decrease as we go down the group?
Decrease.
It will decrease, right? Why? Because of increase in atomic size, because we are adding new and new shells. Okay, so please write here. Ionization enthalpy decreases as we go down the group. As we go down the group. Why? This is because the size of atom increases down the group as new shells are added. On subsequent periods. Okay. Please remember, if we are in the same group, then the period number is changing. Okay, if we are in the same group, then what is changing? The period number is changing. After variation in group, you will write variation in successive ionization enthalpy. Variation in successive ionization enthalpy. In this case, we have already seen for a metal, or rather for an atom, the first ionization enthalpy is going to be the smallest, followed by the second ionization enthalpy, followed by the third ionization enthalpy, and so on. Okay, and so on. Now, in this case, we have a very typical case. If I look at the ionization enthalpy, 1 and ionization enthalpy 2 of two atoms, lithium and beryllium. Okay, so lithium and beryllium, what is the atomic ionization enthalpy for these? It is right 520. And for this, the second ionization enthalpy is 7298. The first ionization enthalpy for beryllium is 899, and the second ionization enthalpy is 1758. So from here you can see that it is easier to remove 2 electrons from beryllium rather than lithium. Can I say that yes or no from this data? If I have to remove 2 electrons from beryllium, it will be easier rather than if I have to remove 2 electrons from lithium. If I compare the ionization enthalpy, second ionization enthalpy of lithium and beryllium, the second ionization enthalpy of beryllium is lesser than that of lithium. Why is that? We have to talk about that. Please let me know when you are done. Then I will tell you the reason. All of you
Yes.
done? Yes or no, please? Done? Okay. Now see here. I am going from lithium. I will do IE1. First ionization enthalpy, I will get lithium positive. Then I will again do IE2. Then I will get lithium 2 positive. Now lithium has an electronic configuration of 1s2 and 2s1. This lithium positive has an electronic configuration of 1s2. And this lithium 2 positive will have an electronic configuration of 1s1. If I go from beryllium, so beryllium, IE1, and it will give me Be positive. IE2, and it is going to give me Be2 positive. If I talk about beryllium, it is 1s2, 2s2. Beryllium positive is 1s2, 2s1. And beryllium 2 positive is 1s2. Okay. Now here you can see that this 1s2 electronic configuration, it is going to be very stable, right? Because it is noble gas configuration. Yes or no? Tell me, guys. Correct? Yes or no? 1s2 is noble gas, na? Helium. Helium has the configuration of 1s2. So this is noble gas configuration. And going from noble gas configuration to a partially filled, that is going to be difficult rather than from partially filled to noble gas. So I hope all of you can see that IE2 of lithium is going to be higher because we are removing electron from a very stable noble gas configuration. Can all of you see that we are removing electron from the noble gas configuration? Yes or no?
Yes.
Yes.
Okay. So we'll write here 2 things. Number 1. First thing, lithium positive has stable electronic configuration of 1s2. Stable electronic configuration of 1s2. But Be positive does not have stable electronic configuration. Does not have a stable electronic configuration. Hence, ionization enthalpy 2 of lithium is higher than that of ionization enthalpy 2 of beryllium. But if you look at the first ionization enthalpy, whose first ionization enthalpy is higher, lithium or beryllium? किसका ज़्यादा है? IE1. For which one it is higher, lithium or beryllium? Wait. यहाँ पे 8 था, sorry. Which is higher?
Beryllium.
Beryllium, right? So we'll write the reason for that also. The beryllium has 1s2, 2s2. Both of these are what? Fully filled, right? So beryllium has stable electronic configuration of 1s2, 2s2. Both of these are what? Completely filled, fully filled. But lithium does not have stable electronic configuration. Hence, IE1 of beryllium is greater than IE1 of lithium. IE1 of beryllium is greater than IE1 of lithium. Please write this down. Let me know when you're done.
Done, sir.
All of you done? Yes or no? Please tell me.
No.
Okay. Fatima, have you learned or have you studied this chapter on your own a little bit? Not a little bit. Have you studied the other topics?
Yeah, sir.
Yeah. You must be having some doubts, right?
Sir,
You
the
don't have
only after ionization therapy, that's when I just start. Nothing else.
which is tough? Electron gain enthalpy.
Yes, sir.
Electron gain enthalpy is tough. Okay. So you stay back. Okay. Once the class is done, you will stay back. Okay. I will take your doubts.
Sir, I don't have doubts, but I haven't reached to that side. I haven't revised it yet, so I don't know.
You haven't revised. So you can't stay back.
No, sir.
No.
No.
Okay. So you have to revise. Okay. You have tomorrow test. Okay. Done everyone? Yes or no? Please tell me. Done everyone? Yes or no? Please tell me. Aisha,
Yes.
Iram. Yes. Okay. Write down this question. Which of the following pair of elements would you expect to have lower ionization enthalpy? Please see lower. Okay. Send the answers. You can send it on chat only. I hope you can see and tell the answers. All of these things, I hope you can see that what this is expecting. NCERT is expecting that you should know the periodic table. You should know the relation between fluorine and chlorine, which is above, like fluorine or chlorine. Do they have the same group or the same period? Similarly, chlorine and sulfur, what is the similarity here? Okay. Let us see. Start sending the answer, guys. What I don't know what you guys are thinking. Chlorine, 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 sulfur, potassium or argon, krypton or xenon. You don't have to explain it. You just give me the answers. I know you will be able to explain. Abdullah, I just don't know what you are answering. This is not an MCQ. Out of chlorine and fluorine, which is going to have lower ionization enthalpy. Out of chlorine and sulfur, which is going to have lower ionization enthalpy. Out of potassium and argon, which is going to have lower ionization enthalpy. Out of krypton and xenon, which is going to have lower ionization enthalpy. Okay, okay, Aisha. Okay. And for krypton and xenon? Okay, very good. Others, you also try? Okay, 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 correct, Iram. Waiting for Devangi, Fahad, and Fatima. First one is correct. Please think about the second. Lower ionization enthalpy. Devangi, lower ionization enthalpy. Second and third is not right. Devangi, please rethink. Okay, Fatima. No, Fatima. Fahad, fourth does not have any option for argon. Okay. So the answer will be for the first one, you will have chlorine. The second one, you will have sulfur. Then you'll have potassium, and then you will have xenon. Why is that? Why chlorine? Because chlorine is down the group, right? It is below fluorine. Below fluorine and more number of shell. Then chlorine or sulfur. So in chlorine and sulfur, the answer will be sulfur because it will have less nuclear charge. That means it is going to have less atomic number. Now, less atomic number, that means less number of protons. And then you will have, after this, one more reason would be what, larger size. Potassium and argon. So in this case, potassium will have the lower ionization enthalpy because argon is noble gas. So if it is noble gas, then it is going to have a higher higher ionization enthalpy. Okay, so potassium will be lower. In krypton and xenon, xenon is going to have lower because it is below krypton. No, large size. Okay. Write the next question. Please write this. Abdullah, your answers
Can
are
you
correct,
scroll
but
up a bit?
yeah, sure. Abdullah, your answers are fine, but I really don't know whether you understand it or you have just written it from somewhere. Unless and until you will talk, I don't understand this. Fatima, did you understand all the reason?
Yes, sir. Can you explain the last one?
Last one. Okay, so for krypton and xenon, which is having larger size? Krypton or xenon? Fatima, tell me. Which is having larger size, krypton or xenon?
Krypton.
No. Xenon is having larger size now. So you have to remember the noble gas and all the groups at least, okay? Because see, it is expecting that you should remember all of these like groups and period, everything. The complete periodic table, not complete, but S block, P block, and the first three transition series of the D block elements. Okay, so if you remember the noble gas configuration, it is helium, neon, argon, krypton, xenon, and radon. So you can see that xenon is lower and it is below krypton. That means it is having larger size. If it is having larger size, it will be easier to remove electron. Understood now, Fatima? Yes or no?
Yes.
Fatima? Okay. Okay, all of you wrote this question, yes or no? Please tell me. Hi guys. Aisha, Devangi, Iram, Fatima, all of you wrote this question?
Yes, sir.
Okay. Now, if you look at this question, they have given a few data here. You have sodium, magnesium, and silicon. Sodium, magnesium, and silicon. And they have given me the ionization enthalpy as 496, 737, and 786. All of them are in kilojoule per mole. They're asking me to predict whether the ionization enthalpy of aluminium, they're asking me whether it will be more close to 575, it will be near to 575, or aluminium will be near to 760. They're asking me this. Okay. Now this question is very clearly, it may seem like, humko kya pata? How would I know? But rather what they are asking is, all of you tell me, between all of these sodium, magnesium, and silicon, is there any value which is between 575 and 760? Is there any value which is between 575 and 760? Yes or no? Tell me.
Yes.
Which values? Sodium, magnesium, or silicon? Whose value is between 575 and 760?
Magnesium.
Magnesium. All of you can
Sodium
identify.
and
Very good.
magnesium.
Sodium and magnesium. No. Sodium is not in between. No?
Sorry, magnesium, please.
Only magnesium, right? Only magnesium. So what they are asking is, you have to compare it. If it is, let us suppose, if aluminium is 575, that means it is what? It is less than magnesium. If it is 760, then it is greater than magnesium. So what they are asking, which one of this is true? They're asking you guys the ionization enthalpy of aluminium and magnesium, which will be higher. Can you see that question? Yes or no now? Can you see the indirect question now? What they are asking? No? Once again,
Yes.
all of you can see. No? Okay, fine. Now, if you look at this aluminium and magnesium, what do you expect? Tell me. Aluminium and magnesium. See, the electronic configuration of magnesium is how much? Tell me. How many electrons? 12 electrons. So it will be neon. Tell me. Neon. 1s2, 2s2, or 3s2? Neon. 3s2, no?
Yes.
3s2. Okay. And aluminium is 13. It will be neon. 3s2, 3p1. Now tell me which will be easier to remove electron, from the s subshell or the p subshell? Easier will be, once again,
Please.
p subshell, right? Fatima, I think you said s now
Yeah.
initially, but it will be p. You understand it now?
Yes.
Okay, fine. So this will be what? Easier. That means easier. So ionization enthalpy will be lower, correct? Yes or no? Ionization enthalpy will be lower, right? So we can say that ionization enthalpy of aluminium is lower than that of magnesium, as in aluminium, electron is removed from 3p, whereas in magnesium, electron is removed from 3s. Therefore, ionization enthalpy of aluminium, it will be nearer to which one? Tell me. 575 or 760? किसके करीब होगा? Tell me, 575 or 760? It is lower than magnesium, no? Yes or no? It is lower than magnesium. Aluminium is lower than magnesium. अरे, what happened, guys? You guys don't answer anything. 10 बार पूछना पड़ता सबको एक एक करके. आप लोग बिल्कुल सबको हम कंप्लेन करेंगे. I'm letting Learnivio know. They will talk to your parents now. Tell me. It will
575.
be
575.
ठीक है. Very good. Okay, so I hope you have seen how the questions will come also, and you have also seen the reasons for the other ones. This is also one of the question. Okay, the ionization enthalpy, first ionization enthalpy of lithium, is less than that of beryllium, but the second ionization enthalpy is higher than that of beryllium. Why is that? You will answer the same thing, 2 points you will write. Okay, and then in the variation of period, you will have two questions, nitrogen versus oxygen, as well as you can get beryllium versus boron. And you have to write these points as it is. Okay, so this ionization enthalpy. And please guys start revising, okay? Please start revising. Those who don't attend the classes, please watch the lecture, okay? When you come for the next class, so that you don't have any gaps in understanding, okay? Fatima, are you sure you don't have any doubts and you don't want to stay? You want to revise?
No, sir, I have to revise.
You have to revise? Okay, fine. Okay. If you have any doubt now, like I am up for a while. So if you have any doubt, then you can just send a WhatsApp to me. Okay.
Okay, sir.
Okay, chalo. Thank you guys. That's it for today. Then we have two, I think, electron gain enthalpy is there after this.